Now you have this Biconking equation, and I'm the type of guy who's like, okay, I have an equation, big deal, what's up with it? Like, not much, right? Well, yeah, you don't know how to solve it, and you just be like, okay, well, I'm eager to do anything I want with it. So I'm just gonna rewrite the equation. I'm just gonna keep the equation up here for reference, right? Okay, and I'm gonna start working from down here. Okay, so you have this equation, and you're like, okay, well, what can I do? Well, the first thing we do is we assume that psi of x comma t is some function of time times some function of space. Okay, we assume that. Right now you're ready to get any solution you can, and if you assume that, then it'll help you out, right? So let's just put it back in there. So I h bar, now remember we're subbing it in, right? So del of yeah, that's just my short form, t times respect to time is equal to negative h bar squared over 2m. Now I'm just gonna sub it in again. So, and if it confuses you at any time, feel free to pause the video. I'm like, yeah, it's not that bad. I mean, you guys should get it. You're all smarties, right? And remember, this now subs back as a function of space and as a function of time. Sorry, I ran out of space there, but that is a function of space and time. That's v psi. I mean, I just subbed it in right up there. Okay, so that's what we have now. This is a derivative with respect to time. So this has to stay constant, right? That's how partial derivatives work. So I'm just gonna move that out. So I'm gonna get times I h bar. Now it's just a function of time, so I can say that this thing just becomes a normal derivative, not a partial derivative. And similarly over here, this is with respect to with respect to the space, right? So this function of time can just move out, and f of t, okay, times. Now same thing happens here, right? It becomes a normal derivative since there's only a function of some time. I mean some space, sorry. I do not know what is wrong with me. That's a 2 right there. Plus v f of t. And now I'm not sure if you guys can see that, but that thing just stayed the same. It's just v psi of x of f of t. Some function of space times some function of time. Sorry if you guys can't see that. If you guys are following along, I mean, you guys shouldn't have much problem. There you go. If that's a little bit better, makes whatever floats your boat. Now what I'm gonna do is over here I'm just gonna take a common factor of f of t, and over here I'm gonna take a common factor of, well, it's already taken out, so I'm just gonna leave it like that. But I was gonna take it out of this thing, but I guess it's already out there, so why go through the same trouble? Okay, I'm gonna take f of t out, and I'm gonna be left with negative h bar squared over 2m times d squared psi of x over dx squared plus v psi of x. Now what I'm gonna do is, I'm gonna divide both sides by psi of x and f of t. And pardon my way of doing it. I mean, it's a quick way we learned in grade school. Okay. What happens is this f of t goes out with that, psi of x goes out with that, and what we're left with is I h bar df of t or dt times 1 over f of t is equal to, now notice, actually, you know what, let me just write it down for a sec before I tell you to notice something, and you guys can copy along if you want, or you can just wait and, like, if you're just like, alright, spare me the details, just tell me what the final answer is. I'll get that in a moment. Okay. Now, notice this is a function of time, solely a function of time. There is no, this guy does not know where this position is, solely a function of time. Similarly, this is solely a function of space, right? There's x, 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 x. There's no t there. That's a 2, by the way, not a t. Anyway, so now this equation tells us that this time is equal to some space, but this guy doesn't know what space it is, and this guy doesn't know what time it is. So they have to be equal to something. Now, they're not. Okay, let me get this clear. They're not, but let's suppose that they were equal to some function of space. Okay. Okay. Say they're not. I'm just giving you this example. They're not. Say they're equal to some function of space. Well, what happens is this guy will work, because as space changes, this space will change. But this guy, he'll just be like, alright, hold up, man, I don't know what space it is, so I can change whatever time I want, but your space won't change at all. So it's not equal to some function of space. Similarly, it can't be equal to some function of time either, because what's gonna happen? This guy's gonna be like, alright, I know what time it is, and he's like, alright, yeah, so I can change up to your time. This guy's gonna be like, wait, I don't know what time it is, I can do whatever space I want, and it's not gonna work out. So it has to be equal to some kind of a constant, and that constant, you already know what it is. It's E. Okay? So I'm just gonna work with that, and for simplicity, this big hunking thing right there, I'm just gonna say that that is just some function of s of x. Okay? Just, it's a shorthand between you and me. Don't ask me why. I'm lazy. I don't want to write that all over again. I'm just gonna write it as s of x. Alright? So let's see what we can do next with that thing, if we can play around with it a little bit more. So we have that E, right? I'm gonna work with this side only, okay, for now. I'm gonna move this f of t over. So E, hold on, so E f of t, okay, is equal to I h bar df of t over dt. Okay, now you can just take a derivative of that, and you would know really quickly, you guys should understand that that is just equal to E of I E of t over h bar. You guys, if you want, you guys can take the derivative of it, or you guys, as I said, can trust me on this one. Okay, now that's what this is. Alright, I'm gonna underline that and leave it just for a second. I'm gonna go to this side. Okay, I'm gonna rewrite that. Actually, there is no point at s of x, because I'm gonna have to rewrite the whole thing again anyways. Oh well, I'm just gonna move psi of x over, so it's just gonna be E psi of x is equal to that thing right there. Now I'm gonna just write that over 2m. Sorry. Alright. For those of you who know what that is, you can tell straight up. It's a good job. I commend you. For those of you who don't, I'll tell you that this thing right here is just a state of definite energy. And if you guys don't know what that is, you might know what the symbol of it is. The symbol is just psi e of x. These are just functions related with the energy of the system, right? Okay, so so we finally got our answer. Alright, and the answer is right there. Yeah, you guys didn't see me write that down, but my bad, it was just a problem that I had. Who cares? Don't worry about it. The answer is right there, right? E to the negative I, E big energy times time over h bar is equal to psi of e to the x, and that is the state of definite energy. Alright, make sure you know that, because that is just each energy is like the function related with each energy, right? And yeah, that's pretty much it. I mean, it wasn't so hard to go through it. Yeah, it was easy. you guys should have understood it. Like, we pretty much did a little bit of calculus, a little bit of subbing in a linear, some algebra there, here and there, and just some basic physics concepts, and we figured out what this solution is. I mean, yeah, there's hype over it, but who cares? You guys did it. Good job, and hope you have a good day, because you guys should have had a nice ride.